Welcome to This Explainer. Today we're diving into something truly fascinating. We are going to explore the striking, almost unbelievable parallels between ancient Hindu texts and modern scientific discoveries. We're unpacking the scientific achievements of Hinduism, moving way past the realm of pure myth, and taking a hard look at the math, the astronomy, and the metallurgy that was quietly hiding within these ancient traditions all along. Let's get into it.
Here is our roadmap for today. We'll be hitting cosmic mysteries, the sun's distance, the math of zero, the iron pillar, and finally, Wood's steel. Section 1, Cosmic Mysteries and Time. To really grasp the intellectual foundation of this civilization, we have to look at one of the earliest ancient Hindu texts, the Rig Veda. This text set a precedent for a culture that absolutely wasn't afraid to ask massive, existential questions. There's this famous hymn called the Nasadiya Sukta, and it has a line that goes, "The gods themselves are later than creation, so who knows truly whence it has arisen?" What's so remarkable here is that it ends with a state of profound mystery. It doesn't just hand down some dogmatic, absolute answer. It openly acknowledges the limits of human and even divine knowledge when it comes to the universe's ultimate origins. And this perfectly captures the epistemological humility of the Vedic seers. It's this exact mindset, a tradition of skeptical questioning and unselfconscious humility before the great cosmic mysteries, that the late astronomer Carl Sagan deeply admired. It really shows us that the core principle of the scientific method, the idea of questioning absolutely everything, has incredibly deep roots in ancient Hindu philosophy. Section 2, Calculating the Sun's Distance. So, building from that philosophical questioning to some stunningly precise astronomy, I want you to ask yourself just how far away is the sun? And more importantly, think about how incredibly difficult it would be to measure that vast distance without the aid of modern telescopes, satellites, or radar. I mean, how would an ancient civilization even begin to approach a problem like that? Well, let's take a look at a 500-year-old Hindu devotional hymn called the Hanuman Chalisa, written by Saint Tulsidas. There's a specific verse in it, Juga Sahasra Yojana Par Banu. If we actually break down the translation of this verse into a mathematical formula, using the conversion factors of that time, it gets really interesting. One yuga is 12,000 years, one sahasra is 1,000, and one yojana is 8 miles. So if you multiply the whole shebang, 12,000 times 1,000 times 8, you get exactly 96 million miles. Now, when we convert that 96 million miles into kilometers, we get 153.6 million kilometers. Let's compare that to modern science, which tells us that one astronomical unit, the average distance from the Earth to the Sun, is 149.6 million kilometers. Saint Tulsidas' poetic verse calculated a distance that is shockingly close to modern science's accepted measurement, centuries before modern astronomy even existed. It's just mind-blowing. Section 3. The Mathematics of Zero. Transitioning from the physical scale of the solar system down into the abstract realm of numbers, we see ancient Indian mathematicians embarking on some seriously bold adventures in algebra. You see, they didn't just invent zero as a mere placeholder, like an empty column on a ledger. They fully embraced it as an active, working integer in complex operations. They even conceptualized this thing called the kahara, a zero-divided number, treating it as a totally unique mathematical entity. That was a massive conceptual leap for humanity. The crucial takeaway here is that mathematicians like Brahmagupta in 628 CE and later Bhaskaracharya in 1150 CE essentially formulated the early rules of calculus centuries ahead of their time. Brahmagupta confidently asserted that 0 divided by 0 is 0, and then Bhaskaracharya actually tackled the concept of infinity, defining any non-zero number divided by 0 as an infinite quantity. They were literally wrestling with the exact concepts that formed the bedrock of higher mathematics today.
And this knowledge definitely didn't stay isolated in India. Brahmagupta's seminal work directly influenced the Arabic astronomical tables of Al-Khwarizmi. These Indian mathematical and astronomical methods were known as the Sidhant, which was basically a corruption of the Sanskrit term Siddhanta, and they were widely exported, fundamentally shaping early Islamic cosmology and, ultimately, the global mathematical tradition we use today.
Section 4, The Rust-Defying Iron Pillar. All right, let's ground all this abstract math back into tangible physical reality. What we're looking at is the famous Delhi Iron Pillar. It's an ancient architectural marvel that has stood out in the elements, completely rust-free, for over 1,000 years.
It's absolute physical proof that the scientific achievements of this era were highly applied, real-world engineering marvels, not just theoretical musings written down on palm leaves. So what is the secret sauce here? Well, the pillar's remarkable preservation comes down to a uniquely high phosphorus content when you compare it to modern mild steel. Ancient Indian artisans actually achieved this by using specific iron-rich waste materials, known as sphaelitic slags, and purposely skipping the addition of lime or calcium oxide during the extraction process. Without the lime there to draw it out, the phosphorus remains securely locked right inside the iron. And because of that incredibly high phosphorus content, this unique iron-hydrogen phosphate hydrate layer forms right at the metal oxide interface. Think of it like a permanent, self-healing armor that completely seals the metal off from the elements, stopping corrosion in its tracks. It's a brilliant chemical defense mechanism, engineered directly into the material centuries ago.
Section 5. The Secrets of Wootz Steel.
Shifting gears from indestructible iron to a famously sharp weapon material, we find Wootz steel. This was a highly advanced crucible metallurgy that originated in South India and Sri Lanka by the mid-1st millennium BCE. It's characterized by an unusually high carbon content, anywhere between 1.0 and 2.0%, and a really unique, naturally forming internal pattern known as carbide banding. The ancient smiths achieved this by heating ore with carbon sources, like bamboo, inside sealed clay crucibles. Sometimes they even used these brilliant wind-driven furnaces powered directly by the fierce monsoon winds.
Now, you've probably heard of Damascus steel, right? It's legendary for its beautiful, flowing, water-like patterns and its incredible razor-sharp edge. Well, plot twist, those fabled Damascus swords of the Arab world were actually forged from imported South Asian Wootz steel ingots. The technology and the raw material itself was a massive export of ancient Indian civilization. Which brings us to a final thought. If an ancient devotional poem can calculate the scale of the solar system, and ancient clay crucibles can out-engineer modern steel, what other scientific truths are still hiding in these ancient texts? We've seen how the scientific achievements of Hinduism span all the way from the cosmic down to the molecular level. It really challenges us to rethink the boundaries between ancient history and modern science. I hope this explainer leaves you eager to dig deeper into these incredible ancient mysteries. Thanks so much for joining me today.